Right. I want you guys to try one example here. Let's say, and I'm going to put some things together on you. Let's say in our denominator, we have x squared plus 3 times x minus 2 squared. In our numerator, we have x cubed minus 2x plus 5. Right. Now I just made these numbers up, so we might get ugly numbers for our answers, but that's okay. We can deal with it. We've got a calculator. Right. So now we've got a mix of things going on in our denominator. Again, pause, give this a shot, and then check your answer by continuing the video later. We have a quadratic factor. And whenever we have a quadratic factor, we need to have a linear thing in the numerator. And then here we have, it looks like it's quadratic, but remember it's the same linear factor twice. So when we have the same linear factor twice, we make that into two fractions, like so, with just a linear term up above it. Yep. And from there, we can go ahead and work this out. It might be a little bit uglier than the other ones we've done, but we can go for it. We multiply through by our least common denominator. And what do we have? Well, in the first fraction, the x squared plus 3 cancels out, so we're just multiplying by x minus 2 squared. In the second fraction, just one factor of x minus 2 cancels, so we have x squared plus 3 times x minus 2. Whoops, I didn't leave enough space. And then in our last fraction, the x minus 2 squared cancels out, leaving us with just x squared plus 3. All right. Now there's one value that we can very easily plug in and get rid of a bunch of stuff, and that is if we plug in x equals 2. See on the left side, 2 cubed is 8, minus 2 times 2, that's 4, plus 5 is 9. On the right side, x minus 2 is 0, so that term goes away. X minus 2, that term goes away. And over here we have 4 plus 3 is 7 times d. So right away, we can get d equals 9 over 7. All right. Now, from here, it's going to be a little bit uglier. We do need to expand everything out, I think. We could plug in more values for x and get equations, but I think expanding everything out is going to work out a little bit better for us, even if it is going to be a bit ugly. See if we distribute this through, we got an x cubed minus 2x squared plus 3x minus 6, and then we have dx squared plus 3d. Okay. And then distributing this, let's see, we have ax cubed minus 4ax squared plus 4ax plus bx squared minus 4bx plus 4b plus cx cubed minus 2cx squared plus 3cx minus 6c plus dx squared plus 3d. Woo! Big nasty equation there. But then we can collect our terms and see what happens here. Let's see. X cubed minus 2x plus 5 equals, let's see what we've got for cubed. We've got an a x cubed and a c x cubed. So we just have a plus c x cubed. Then for our x squared, we've got a minus 4a. We've got a b. We've got a minus 2c plus d. That's not going to be very helpful. That's a lot of values. Then for x, what do we have? We've got a 4ax. We've got a minus 4bx. Got a minus 2cx. And no. Oh, sorry, that's the minus 2cx squared. We've got a plus 3cx. And then for constants, what do we have? We've got 4b minus 6c plus 3d. Woo-wee! That's fun. So we have a system of equations that we can use to solve this. So this gives us a big system of equations. A plus c, x cubed. Over here we have 1x cubed, so we have a plus c equals 1. And we have minus 4a plus b minus 2c plus d equals, that's times x squared. Over here we have no x squareds. And we have 4a minus 4b plus 3c times x equals negative 2. And then we have a 4b minus 6c plus 3d equals 5. But we've already solved for d, so our system's a little bit simpler. d is 9/7, so that's plus 9/7. So we can move that over. We can say, okay, we've got a plus c equals 1 minus 4a plus b minus 2c equals minus 9/7. And we've got 4a minus 4b plus 3c equals negative 2. And then we have 4b minus 6c plus 3d. So 3 times 9/7 is 27/7. Then we have 5 minus 27/7, which is 8/7. All right. So we have a system of equations. We have more equations than we need. We have 3 variables to solve for. And we can start doing whatever we want to. Let's see. This, we could eliminate b from an equation and put it together with this one, or we could eliminate a from an equation and put it together with this one. It doesn't really matter. I'll just add these 2 bottom ones because they're nicely set up for elimination. Minus 4b plus 4b goes away. So then we have 4a minus 3c equals negative 2 plus 8/7 minus 6/7. And then we have this first equation. We can multiply by 3, and we get 7a equals 3 minus 6/7, which is 15/7. So we get a equals 15/49. We can back substitute and solve. We know that a plus c equals 1. So c is 1 minus 15/49, which is 34/49. And now we have, what do we have? We have d, we have a, we have c, so we need b. Pick an equation that has b. Say this one. And we have 4b minus 6 times 34/49 equals 8/7. So we have 8/7 plus 6 times 34/49. And then 4b equals that, so we divide by 4. Frac. And we get b equals 65/49. So, again, not the prettiest numbers and a long process, but we can work through it and get our answer. Now all that we have left is to write the answer. ax plus b, 15/49, 65 over 49, so we can write that as 15x plus 65 over 49, x squared plus 3, plus c, 34 over 49, times x minus 2, plus d, 9 over 7, times x minus 2 squared. And we have the partial fractions decomposition. Always check your answer, especially when it's a long process. And hopefully I've done this right, because if not, I would be sad. I have to go back through this and find my error somewhere. So that's my original expression. My answer, got 15x plus 65 divided by 49x squared plus 3. 34 over 49 times x minus 2 plus 9 over 7 times x minus 2 squared. Hey, good for me. Yeah. So that's how you go through partial fractions decomposition. So let me just summarize. Do your pre-steps that we talked about. Remember, you divide if you need to, factor the denominator, and then write out your linear and quadratic factors in the format that you need to. Then we multiply by the least common denominator to get rid of our fractions. Then what did we do? We plug in convenient values of x. It's generally the easiest thing to do first with any linear factors. And then, if necessary, expand and equate coefficients. If necessary. If you can, just keep plugging in values for x, and by all means do that. And then finally, solve for our parameters, a, b, etc. And then write our expression with those values plugged in. So that is how we do partial fractions decomposition.